Hi everyone, welcome to the 8th module of this course on microsensors and nanosensors. In this module, we are going to talk about tactile sensors and pressure sensors. This is the first lecture in this module. So, in this tactile and pressure sensors, we will take that one by one. We will first discuss about tactile sensors and then we will take up the pressure sensors. So, what is a tactile sensor? The basic question is, we have seen in all the modules that we first learn about that particular sensor and then we see its application and its fabrication. Okay, that is what we are going to do in this module also. So, let us learn about tactile sensors. So, tactile sensors are the devices that mimic the sense of touch to human. So, you can understand it as a touch or not touch sensor. Okay. So, you do not have to quantify for a force or pressure which is giving the touch feel. Okay. So, in the previous module, we have seen mostly the force sensors where please note that we have quantified the forces, okay, that this millinewton or this particular nanonewton force has been applied or this micronewton force has been applied. Here you do not have to worry much about the quantification, but at least the qualitative description of the applied force and applied pressure is sufficient, but then it has to be very precise and it has to be fast enough to detect it within say millisecond or even in a fraction of a second. Okay. So, they are the devices that mimic the sense of touch in human. Okay. So, the device basically detects some physical interaction. This interaction can be in the form of force, it can be also in the form of pressure or say in kind of some vibration or feel of the texture. Okay. So, all of these is categorized under tactile sensor. Okay. So, it is a sensor. So, what it does, it converts this mechanical stimuli into electrical signal. Okay. Please recall the definition of a sensor that we have discussed in the first module. Okay. The application of these tactile sensors are really vast. Okay. I mean in robotics it is very popular for gripping, manipulation, object texture recognition and electronic skin. Okay. In medical, prosthetics and surgical tools are based on these tactile sensors. So, then in consumer electronics, we see every day our device which is based on a tactile sensor, which is our mobile phones. Okay. The touch sensor that your mobile has is basically a tactile sensor which you interact, I think nearly every day. Okay. So, all the touch interfaces are based on these tactile sensors. Okay. Then in the wearable sensors like the smart watches or nowadays it is coming in the form of other wearable devices, all require actually a touch sensor, okay, or a tactile sensor. Okay. In industrial automation also for surface inspection and all, you need for quality assurance purposes these tactile sensors. Okay. So, I mean these are the some of the application that I have taught, I have discussed, but then the application of tactile sensors is even vast than what we are discussing right now. Okay. So, this tactile sensors are a special kind of force or pressure sensor. We are not taking the vibration and texture things in this module because we have only 5 lectures for this tactile and force sensors. Okay. So, we will see some of the example particularly at the fabrication front, but we will discuss I think all the principles on which these sensors can be based upon. Okay. So, you have already made some fundamental basis till module 7 where I think in this module it will be very easier for you to grasp the type of type of transduction technique that is used in the tactile sensor fabrication. Okay. So, the tactile sensors are, as I have mentioned, are the special type of force or pressure sensor, where you are not worried about quantification, but you are only worried about qualitative analysis, right. So, like if force is applied or not applied, or if the pressure is applied or not applied. I think that is more than enough to give you a feel that something has been touched or it has not been touched. Okay. These sensors are characterized by very small thicknesses of various materials, particularly thin film of piezoresistive or piezoelectric materials, based on which these devices works. Okay. They can be simply fabricated by creating situation where force or pressure can be built up between two objects that are close each other. Okay. We will see some of the fabrication strategy. Here you can see one schematic is there. You have, say for example, this piezoresistive material placed over here, okay, and say initially when there was no deformation, okay, these were two different films, okay, and in between you have a stretchable film. Okay. Now, when you apply this pressure, and of course these points are hinged, okay, this object will go down and it will it will bend depending on what quantity of force has been applied. Okay. And it has enough flexibility, this will touch this particular portion. Okay. And when there was some electrical signal, say V, when it touch, it is creating some kind of short circuit. Okay. So, this voltage will be 0. Okay. So, this null value will suggest that it has been touched. When there was a voltage, it will suggest that there was no touch. Okay. All right. Similarly, you can have other arrangements to have this touch or not touch feeling. We will take some of the fabrication strategies to develop these tactile sensors. Okay. The example of this tactile sensors include robotics, where the tactile sensors can be positioned on the fingertips of a mechanical actuator. Okay. So, you have a mechanical actuator in the form of robotic hand, okay, and if it is gripping some object, like here I have given an example of simple tennis ball, okay, if it has gripped or not, I think a feel of touch or not touch is more than enough for this robotic hand. Okay. Of course, we have seen that it also requires force sensor, where you will have a feel that what quantity of force you have to apply so that the object that it is picking up is not breaking, but before that one more layer is there, which is the tactile sensors layer, okay, which will give a feel that actually your robot is touching that object or not. Okay. So, this is one of the example, but this hand, the robotic hand can be useful not only for this picking up of these objects, but it is also helpful in surgery, and also all this robotic surgery and all require this kind of tactile sensors. Okay. So, when the object is touched by this robotic hand, it actually generates a feedback upon developing a contact with the object. Okay. So, when you have a feedback that the object has been touched, okay, accordingly your you can take decision, the microcontroller will take decision that how much force has to be applied to grip the object. Okay. So, this is very much like a tactile sensors that work in a natural human body, which is our skin. Okay. When somebody touches, or if that person goes from the nearby place, but he doesn't touch, okay, we can have that particular feeling. Okay. So, this tactile sensor is very much inspired by the human skin. Okay, we have seen that all these sensors are basically that we are discussing in this course are naturally inspired. Okay, like we have discussed about gas sensor little bit. Okay, the gas sensors have a feeling of it is inspired by our nose. Okay, so we have a feeling of if there is some smell or there is no smell. Okay, and then these sensors go beyond that, and it give you the quantification data also that okay, this gas is present in this quantity, right. So there are various kind of tactile sensors, like touch sensor is one of the important type of tactile sensor, but then you have special kind of sensor. We'll see what is special tactile sensor. And then we have also a slip tactile sensor. So three different type of tactile sensor based on how it works and what data point it acquire. You have touch tactile sensor and special tactile sensor and slip tactile sensor. Let us see first the touch tactile sensors. Okay, touch tactile sensor or touch sensors detect and measure the contact forces at a particular point. Okay, it generally function as a threshold or binary devices detecting either the presence or absence of touch. Okay, so please note that although I am talking about non-quantifying the applied force, but then also it will be very much beneficial if I can quantify it to particular amount of force. Let's understand this from an example of a elevator. Okay, so I have this elevator and it has multiple switches where it says that this is floor 1, this is 2, 3 and 4. Okay, this switch, I mean these are based on, these buttons are based on touch sensor, for example. Okay, now I will touch this, say I am at first floor, I will touch say a button which will take me to fourth floor. I am basically applying certain force here. Okay, now please note that, I mean this will take me to the fourth floor. Okay, now please note that if by mistake you touch this button, okay, or if you are traveling with a kid, if he touch this button 4, okay, what will happen is, although you wanted to go to say second floor, okay, it will take you to the fourth floor. Okay, that's why these touch sensors are made like a binary devices. Okay, so it will only respond to a force which is beyond a threshold point. Okay, say for example, I have fixed for my elevator that if I apply say 10 micronewton force, okay, or say 10 nanonewton force, if it is very sensitive, okay, on this, okay, on a button, then only it will respond. Okay, or you can understand it from the previous example, where if you remember, we have seen two different objects, these two different objects in which there is a filler of some material, or there is another film. Okay, this is film 1, this is film 2 and this is film 3. Okay, now I told you that there is some initial voltage, okay, between these two films, film 1 and film 2. Okay, there is already a voltage between it. Okay, so I am continuously monitoring that voltage. Okay, now I have applied a force F, okay, which is say 1 nanonewton. Okay, now what will happen is, this film 2 will bend to certain extent, okay, but it will not be touching this film 1, okay, because it require 10 times the force that is being exerted right now. Okay, right. Similarly, in this elevator example, if I apply, say if my kid can apply say 1 nanonewton force on the button, it will not respond. Okay. But if the elderly grown person, if he touch it, okay, touch this button with a force which is greater than 10 nanonewton, okay, it can be of say 100 nanonewton, okay, it can be say 80 nanonewton, it can be 60 nanonewton, anything above this 10 nanonewton will take me to the fourth floor, which is the correct value, right. So, beyond 10 nanonewton force, anything it is taking as a force which is required to pull up this elevator to fourth floor. Okay. So, this is these touch sensors are basically a threshold device or a binary device which will respond if the applied force is beyond the threshold value. Okay. So, if it is beyond the threshold value, it will consider it as touch, or if it is less than that, it will take it as no touch. Okay. Then we have a special tactile sensor or spatial sensor. So, these sensors detect and measure the spatial distribution of forces that is applied perpendicularly across a defined sensing area. Okay. So, this is followed by the interpretation of this spatial data. Okay. So, these sensors detect and measure the spatial distribution of force applied perpendicular across a defined sensing area. Okay. So, this is, for example, this is the area in which I want to quantify the touch sensor, or I want to quantify the touch. Okay. Consider it as a say keypad. Okay. Better let me give an example of a say music system which is our keypads. Okay. It is a touch kind of keypad. You might have seen it in various apps also. There are various apps present in different Play Store or iOS that can turn your mobile screen into a piano. Okay. So, you have various keys over here, and when you touch this area, it will generate different sound. When you touch this area, it will generate different sound, and so on. Okay. So, it is basically using your screen's touch data or touch pattern to create certain kind of sound, okay, by certain kind of signal processing and all. This is a good example of spatial tactile sensor. So, these sensor detect and measure the spatial distribution of forces applied perpendicularly across a defined sensing area. So, these are the defined sensing area. This is followed by the interpretation of this spatial data. So, this can be interpreted in various means. It can be used for creating certain amount of sound, or it can be interpreted to create certain kind of pattern. Okay. So, a spatial sensing array can be considered to be a coordinated group of touch sensor. Okay. So, these areas, I mean each point in this area can be considered as a coordinated group of touch sensor. So, if you are touching this position, okay, your signal processing unit knows that, okay, the coordinate say x1, y1, z1 has been touched. Okay. So, they have to give a signal say in the form of say voltage say V1. Okay. If you touch this particular area on this spatial tactile sensor, say that the coordinates are x1, y1, z1, and you have touched it at time t1 and this at time t2, this will generate a voltage V2. Okay. Similarly, if you are this time t1 and t2, there is only small lag between these two. Okay, this will keep on generating this voltages V1, V2 and so on. Okay, and accordingly the data will be generated or a decision will be taken. Okay. So, a spatial sensing array can be considered to be a coordinated group of touch sensors. Okay. Then there is another kind of tactile sensor which is known as slip tactile sensors. Okay. So, these slip sensors detect and measure the movement of an object relative to a sensor. So, you have a sensor and how a object is gliding or moving, okay, it will, or it is slipping, will be detected by this slip tactile sensor. So just a feel of touch that something is slipping is more than enough to detect this phenomena of slip. Okay. So this can be accomplished either through a specially designed slip sensor. You can either have a specially designed slip sensor, or what you can do is you can analyze data from a touch sensor, or if you have a special sensing array data, I think it becomes very easy to find this slip. Okay. So consider that there is a wheel which is slipping between these two planes. Okay. Now I have a special sensing array placed on both these planes. So this is say sensing array, and it is capturing data. Say this is point P1 on this object. This is say point P2, this is point P3, this is point P4, and so on. Okay. Now this point where it is touching is point D1. Okay. On this special sensing array, this point is D2, this is D3, and so on. Okay. Right now the point D1 on this special sensing array is touching the point P1. Okay. Now when it slips, this P1 point moves to point D2, while this P2 shifts to point D1. Okay. So with this movement, same thing will happen with P3, P4, and so on. Okay. So what you can do is, if you collect all this data and analyze it, you can understand the pattern of slip of this wheel inside this two different beams in which it is sandwiched. Okay. So this is a perfect example of slip tactile sensor. Okay. Please note that working principle of all these force sensors or tactile sensors is based on, deformation that a material goes under the applied force or under the applied pressure. Okay. So deformation changes electrical property or optical property, or sometime magnetic property. We'll see some of them. Okay. And accordingly it can be converted into readable signal via the embedded circuit on the same board. Okay. So these tactile sensors uses different modes of transduction. Okay. The modes can be resistive, it can also be piezoresistive. We'll see the difference between these resistive and piezoresistive tactile sensors also. Okay. There are effects like tunneling effects which can lead to touch or not touch kind of feeling. So tunneling effect has been used to develop tactile sensors. Then other kind of transduction techniques are available, like capacitive optical, ultrasonic, piezoelectric, magnetic, etc. Okay. So on all this, I think based on all these transduction principles, we have seen one or more sensors in our previous modules. So it will be very easy for us to understand how a tactile sensors can be built using the same transduction technique on which other sensors has been fabricated. Okay. Let's take an example of say resistive tactile sensor. Okay. So in the resistive tactile sensor, the device actually measures the resistance across a pressure sensitive material. Okay. So you can understand that by so the material itself is bending, and you are actually not using the piezo phenomena here. Okay. The material is bending, and because of this you are creating some kind of resistance change. Okay. So the structure is very simple, and the older older touch screen mobiles which were not that responding, that were not that sensitive as compared to the modern touch sensors or modern touch screen mobiles. Okay. They were based on resistive principle. Okay. So mostly the response is slower, and since the resistance is varying, it takes certain amount of time. So they are slow to respond. Okay. Then comes the capacitive tactile sensor, on which most of our touch screens are based upon. So what happened is capacitance changes due to variation in the gap between two conductive plates. It is simply based on the capacitive phenomena. If you remember, we have discussed this in the previous modules, where we have taken the formula C equal to epsilon A by D, and if this is two different plates, and if you are applying a pressure over here or a force over here, if the distance between these two plates is decreasing, okay, say if this one plate is fixed and one is changing, the gap between these two plates, okay, this D will vary, and based on that you have capacitive tactile sensor. And since this variation is very sensitive, these devices are usually very sensitive, and their response is also quite fast. Okay, so mostly these touch screens are based on it. Okay, and then you have robotic grippers and other kind of surgical tools also based on this capacitive tactile sensors. Okay, then you have piezoresistive tactile sensor, where the resistance changes with the applied pressure, but here the material is piezoresistive in nature. Okay, this has a natural tendency to change its resistance, so you will find lot of sensor with the piezoresistive phenomena in the market. They are also low cost devices and have decent kind of sensitivity. Okay, so mostly it is used for a low cost robotic skin development and for pressure mapping kind of applications. Okay, then there can be tactile sensors which are based on piezoelectric phenomena. Okay, so this kind of device actually generate voltage when they are mechanically stressed. Okay, as we have also seen in case of force sensor that piezoelectric force sensors were mostly suitable for the application of dynamic force measurement. If you recall, we have discussed that these piezoelectric force sensors are the basic building block or basic behind the accelerometers, piezoelectric accelerometers. Okay, because it has a natural tendency to measure the dynamic forces, and they are not that accurate for static force measurement. Okay, so similarly you can think that they have these piezoelectric tactile sensors are excellent devices for detecting dynamic forces. Okay, and you will find that mostly the vibration sensing and impact detection kind of application utilizes the piezoelectric tactile sensors. Okay, then there are various optical tactile sensors also available, where the device detect the deformation using change in the light path or change in its intensity or change in other phenomena, like we have seen that for interferometers there is a change in path length and other phenomena on which these optical tactile sensors are based upon. Okay, the advantage of this kind of tactile sensors are you do not have to put extra effort to make it immune to the electromagnetic interference or to reduce the effect of electromagnetic interferences. So usually they are based on optical phenomena or based on photons. So basically they are mostly immune to the electromagnetic interferences. Okay, and that's why all the sophisticated application like say medical tools are based on this optical tactile sensors. Okay, then another good advantage of this optical tactile sensor is that it can work in the harsh ambients, like where you want little effect from say temperature or say moisture condition in the ambient. Okay, so in those conditions also this optical tactile sensors are very much helpful. Okay, then there are tactile sensors based on magnetic effect. So the magnetic field changes due to the displacement or applied pressure. Okay, so the advantage of this kind of tactile sensors are it can detect shear as well as the normal forces. Usually shear forces are little difficult for other kind of devices like capacitive or resistive sensors, but for magnetic tactile sensors shear forces can also be detected. Okay, and that's why it has found applications in position sensing. Okay, And in our mobile phone, if you see, there is some haptic feedback, okay, when you touch, okay. So this haptic feedback is basically is an effect of magnetic tactile sensor, okay. Then yeah, there are ultrasonic tactile sensors, which uses ultrasonic waves to detect surface properties as well as the applied force, okay. These ultrasonic tactile sensors have very high precision, okay, and similar to the magnetic force sensors or magnetic tactile sensors or optical tactile sensors, they can also be non-contact in nature, okay. It is helpful in surface profiling, and they are very much sensitive towards the applied touch, okay. So that is the basics of tactile sensors. So in today's class, I think I have just covered the basics of tactile sensor, including different type of tactile sensors like touch, spatial and slip, and we have also seen different transduction phenomena on which this tactile sensors can be based upon, okay. In our next lecture, which will again be on tactile sensors only, we will see some of the fabrication strategies to make these tactile sensors, okay. We will see that how tactile sensors can be built upon using the simple objects that is available in our laboratory, okay. So I think that is more than enough for this first lecture. We'll again meet in second lecture with more discussions on tactile sensors. Thank you.